In this video, we will discuss about the Kirchhoff's laws. When we turn on the light switch, the light bulb comes on immediately, right? Why does this happen? What is going on inside the wires connecting the switch and the light bulb to make the bulb light up? If we could look inside the wires, we would see that billions of tiny electrons moving through the wires of the electric circuit. And the energy of these electrons is what makes the bulb light up. To understand how an electric circuit works, we must know about the currents and voltages around the circuit. A German physicist named Gustav Kirchhoff formulated circuit laws, which can help us in understanding the current and voltage in a circuit. These laws are called Kirchhoff's laws. They are Kirchhoff's current law (KCL), Kirchhoff's voltage law (KVL). Kirchhoff's laws are the heart of circuit analysis. That is, these are basic tool set that we need to start analyzing circuits. Let us discuss what is Kirchhoff's current law and how it is applicable to the circuits. It is also called as Kirchhoff's first law. It states that the algebraic sum of all the currents at any point in a circuit is equal to 0. To understand this, let us consider an example. Here, the algebraic sum of currents is equal to 0. That is, the algebraic sum of all currents around the point is equal to 0. We might get surprised how we got negative sign for I3, I4 and I5. It is because, based on Kirchhoff's current law, if we consider the incoming currents to a node as positive, then the leaving currents from the node must be taken as negative. In the example, I1, I2 and I6 are entering the node, while the currents I3, I4 and I5 are leaving. So we get the above equation can also be written as sum of incoming currents equals sum of outgoing currents. Let us consider some other examples and apply the KCL. Example 1. In this example, the current IA enters while IB exits. So, the equation becomes the current IA minus IB is equal to 0. That is, IA equals IB. Example 2. In this example, the currents IA, IB and IC enter, while ID exits. So, the equation becomes, that is, sum of the currents IA, IB and IC equals ID. Example 3. In this example, the currents IA and IB entering the node, and IC, ID leaving the node. So, the equation becomes, that is. Let us discuss what is Kirchhoff's voltage law and how it is applicable to the circuits. It is also called as Kirchhoff's second law. It states that the algebraic sum of all voltages around a closed loop is equal to 0. This law is applicable to an electronic circuit that contains a closed path. To apply KVL, we must understand the direction of polarity in a circuit. In electronic circuits, conventional current direction is opposite to the flow of electrons. For example, let us take a simple circuit. We know that the conventional current flows from the positive terminal of the source to the negative terminal of the source through the circuit. So, the current direction in the circuit is clockwise. And also, the current flows from positive end to the negative end of the resistors. So, the current entering point becomes positive, and leaving point becomes negative. So, the point A and D are positive, and B and C are negative. For applying KVL, we can assume the current direction, either clockwise or anti-clockwise. If the assumed direction is in the same direction of the actual current, then we take a positive sign for the voltage drop across any element. If the assumed direction is opposite to the actual current direction, then we take a negative sign for the voltage drop across any element. By applying KVL inside the loop, we get that is. Thus, by using Kirchhoff laws, we can understand the currents and voltages in any electric circuit. In this video, we have discussed about the Kirchhoff's current law and Kirchhoff voltage law.